I wanted to do a quick demo of a program that I've been working on. Suppose we've got this zip file that we want to take a look at. I'll explain the shallow part in a second here. So we look at it and it's got a README, a ping, and it looks like a hard drive image. So if we want to take a look at that, we can see that it's got multiple partitions. If we want to look at the ProDOS one, we can pick that one out. Okay, so it's got some files, directory, and the directory is a shrink disk image. So if we want to look at that, we can see that it's got some documentation, but it doesn't have the the actual implementation of GeoShrinkit, which is over here in this Apple single file. So if we wanted to add it, we would need to unpack the zip file, extract the Shrinkit archive, add the Apple single contents, and then put everything back together. Or we just do that. And as you can see, it's got the resource fork, the file type information, all of the goodies. If we get rid of the depth argument when we're viewing the archive, it will actually expand it to a reasonable depth. So it shows you all the embedded volumes, but doesn't actually chase into everything. If you really want it to go into everything, you can say depth equals max, and it will. That gets really exciting on large FTP site mirrors. So let's look at something else. So we've got this other file over here. It's a DOS disk, and it has a few files on it. The length column is how many bytes you would read if you'd used load or bload, or you read it as a sequential text file. Storage is how much space it actually requires. So this needs one sector for the program, one sector for the track sector list. These are clearly oversized. The reason for that is there's a length embedded in B files, which we can see if we look at it in raw mode. So it actually needs 8K of storage plus the track sector list. But this is a whole lot larger. And what's going on here is that this is a random access text file. The first record was empty, so there was nothing to read like a sequential file. And with these kind of files, if you haven't written to a particular sector, it doesn't get allocated. So even though the file itself spans this many bytes, it only takes this many to store. If we wanted to extract this file, all we have to do is extract it as raw. We get the whole thing, we add it as raw, everything is great. The tricky one is this, because if we extract this as raw, we get 125K, which is, most of a disk, if not all of a disk for an old 140K DOS 3.3. So how do we move this file between two different archives without expanding the thing? So I thought about ways of preserving the sparseness for when you extract it, so then you can put it back together when you add it, and finally decided that I was just going about it the wrong way. So let's create a disk image to put things into. We'll make it 40 tracks just for fun. And let's just copy the files. So we've picked the source volume. We're going to just copy the things that end in sample, and we're going to put it into this disk. And if we look at it, we can see that's exactly the same length, exactly the same storage. So this command does a few other things. Creates things, can copy blocks and sectors around, file conversions, sector editing, a bunch of different stuff. This particular demo is being run on Linux. The command runs right now on Linux, Mac OS, and Windows. You may be wondering if there is a GUI tool like the original CiderPress. And the answer is a qualified sort of. Um, so this is more of a proof of concept at this point, but you can kind of see what's going on. So this is the same disk we were just looking at. So it's got uh, the zip contents, it's got the partition map. Here's the ProDOS volume. Here's an HFS volume, and then for the ProDOS and HFS, you can see they've got a directory chart over here. So you can move between directories with this, or you can double click on things to move through them. Um, I should mention this barely works. None of these options actually do anything right now. They're just kind of here for show. But there's a few things that work. So let's take a look at the file viewer. So this is a lot like the old CiderPress file viewer, except the options are now kind of out in front of you instead of scattered here and there. It's got some new things that are just sort of fun to play with. A bunch of buttons that do absolutely nothing. The options reconfigure for each individual type of file. This is new. This is a random access text viewer. Right now it's getting the record length from the aux type of the file. You can put in something else and have it do awful things, but really it's 2K records for this file. If you looked at it in text form, it would look like this. So there's the 0, there's all 2047 null bytes, there's 1, and so on. This will get output as a comma separated values file, so you can bring it into a spreadsheet. One of the other things that this can do is it can now identify sparse sections of files, so you can just kind of skip over them. So all this stuff is written in C#.net. The GUI stuff is currently just a proof of concept. It's Windows only, but the command line tool will run on just about anything, anywhere that the .NET runtime runs. I know that not everyone wants to download and install the .NET runtime, so I have made self-contained packages where you just download one thing and it should all just work. The self-contained ones are about 30 megabytes larger, but in this day and age, you'll never even notice. And that's it.